So if we have that y is equal to tan x, and we know that if you were to differentiate this, it equals sec squared x. However, if you're in an exam, you may forget this, and you may need to differentiate tan x, for example. So how would you go differentiate tan x? Well, this is how you would do it. So what we can do first is we can change that tan x into sine x over cosine x. So if we do that, we have this. And now what we can do is this is in the form of a fraction, so we can use the quotient rule now to differentiate it. So loads of different ways you can think of it. If I make u equal to sine x, and I'll make v equal to cos x, okay, now we can just differentiate these. So we get u dash, that would equal cosine x, and we can have v dash, that would equal minus sine x. You can also change it to f of x and then have g of x, h of x as well. It's up to you. We'll use u's and v's this time. So now that you've done that, now we can apply the quotient rule. So with the quotient rule, it will be u dash times v. So in that case, that will be a cosine squared x minus u times v dash. So in this case, that will be a minus sine x times a sine x, which makes a positive sine squared x. Okay, and that will all be over v squared. Well, v is just cos x, so that would all be over cos squared x. Okay, so now I've done that, this would be dy over dx. And now we should simplify this down. Well, if we simplify this down, what do we know? Well, we have something in the form of, we have cosine squared x plus sine squared x. Well, that is a trig identity, because that just equals 1. As we know from the trig identity, cosine squared x plus sine squared x equals 1. So that would just be 1 over cosine squared x, which therefore equals sec squared x. So even if you're in an exam and you don't remember what the derivative of tan x is, you can just work it out on the spot using stuff like the quotient rule. You can work it out. So imagine now we had to differentiate y is equal to tan to the 4x. So how would we do something like this? Well, again, now that if we know that the derivative of tan x is sec squared x, okay, what we can do for this question is we can use the chain rule. So again, that's another lesson I did earlier on this channel. And if we go over the chain rule, well then let's let u equal tan x, okay? And then that means that y will equal u to the 4. So then if we differentiate x now, we'll get du over dx. That would equal sec squared x, as we just looked at. And then dy over du would equal 4u to the power of 3. And now all we need to do is we know that when it's in this form, we know that dy over dx is equal to dy over du times by du over dx. So it's just going to be our 4u to the power of 3 times by the sec squared x. And now once we've done that, we just put in whatever our value of u is, we can put that back in. In our case, that was tan x. So we would just get that it would be 4 tan to the 3x, and then that would be sec squared x. So another one we need to remember is that if we have something like y is equal to cosec x, then if we differentiate that, that would equal minus cosec x cot x. But again, if you're in an exam and you need to differentiate this and you don't remember what it is, how can we differentiate cosec x? Well, let's go over that now. So what do we know about cosec x? Well, we know with cosec x, that is the same as 1 over sine x, okay? And then again, it's in that nice fraction form. We can just use the quotient rule. So if we use the quotient rule, we would have u as 1, and we would have v as sine x, and then u dash, well, that's just 0. if you differentiate 1, it just gets 0. And if we differentiate v, you get a cosine x. And then if you do the quotient rule formula now, if you do that, you would get, it would be a u dash times v, which is a 0 times sine x, which is 0, so we don't include it, minus a u times v dash. In this case, that will be a minus cosine x. So far we have that dy over dx is equal to minus cosine x. And then that is all over v squared. V squared is, v is sine x, so v squared is sine squared x. And now if we just simplify this down, we'll get a minus cosine x over a sine x, and that is effectively times by 1 over sine x. So if I scroll up now, so therefore we know that a minus cosine x over sine x, that's just a cot, so that will give us a minus cot x, okay, because that's just 1 over tan x. And then we're just left with a 1 over sine x. Well, 1 over sine x is just cosec x, so it'll just be a cosec x. And then if you want to, just you can rearrange it, so it's minus cosec x cot x. So remember, with any of these questions, if you're ever unsure what it is, you can always just differentiate it like normal and you will get the same answer. So for our next question, we need to show that the derivative of arc sine x is equal to 1 over the square root of 1 minus x squared. So this question is a bit more challenging, but once you understand it, it will be fine. So what do we know first? Well, if we have y is equal to arc sine x, then arc sine x, that is just the inverse of sine x. So if it's the inverse of sine x, then effectively we can say that x is equal to sine y. Now, if you're unsure about that, well, let's use a quick example here. Is that if you had something like, let's say y is equal to the inverse sine, right? So let's say the inverse sine, if you just need a calculator as well, feel free. If we do something like this, where we have y is equal to the inverse sine of a half, right? If you put that into your calculator and use in degrees, right, that would give you the answer that y is 30, okay? Now let's think of it the other way. If we knew what y was and we want to look at x, well, if we just do it here, if we had x is equal to sine 30 now, you put it into your calculator, you would get a half. Therefore, if we have something like y is equal to arc sine x, we can also just do the inverse of that. And if we do the inverse of that, well, if the arc sine x is the inverse of sine, that must mean that if we bring that arc sine to the other side of the equation, then it will just be a sine. And I've just shown you how that works then, if you're just a bit confused. So just remember that. Do not get it confused. Do not think that arc sine x is the same as cosec x, because even though both of them can be written like sine, like this, both of them can be written like sine to the minus 1x, they are not the same. So just be wary of that. They are completely different. Arc sine x is the inverse of sine x, the complete inverse. So if you are doing if it's the inverse of sine x, if you want to bring that arc sine to the other side, then therefore you have to sine both sides. So going back to the question, we will know that x is equal to sine y. So if we have that, we can now differentiate this in terms of y. So if we differentiate in terms of y, therefore we get dx over dy is equal to cosine y. Now, we want the derivative of arc sine x, okay? So we know that we need to differentiate with respect to x. However, we've got dx over dy. So what can we do to dx over dy? Well, one thing we can do is we can just flip it. So we have dx over dy. We can change that to dy over dx. And if you change that, you're now left with 1 over cosine y. So now this is dy over dx. This is what we want. We want dy over dx. But how can we now change this cosine y to get it into some form where it just has x's in it? Well, if you remember this trig identity that we have sine squared y plus cosine squared y is equal to 1. Well, if we were to rearrange this and to get it in terms of cosine y, that would just be cosine squared y is equal to 1 minus sine squared y, and therefore cosine y would just be the square root of 1 minus sine squared y. They may be looking at that and be like, how does that help us? Well, if we were to write that in, we would get dy over dx is equal to 1 over the square root of 1 minus sine squared y. And why does that help us? Because, well, over here, we have this thing here where we say that x is equal to sine y. So if we have x equal to sine y, that must mean that x squared must be equal to sine squared y. And if we know that, therefore, that would just be 1 over the square root of 1 minus x squared. So for this question, we have that x is equal to cosec 5y. We need to find dy over dx in terms of y. And then after that, we need to find dy over dx in terms of x. So for the first bit, you want to find dy over dx in terms of y. Well, we know what x is, so we can actually differentiate x with respect to y first. If we do that, we get dx over dy. And remember from one of our previous questions we did, we know that cosec x, that differentiates to minus cosec x cot x. So in this case, if we have cosec 5y, well, that 5 would come out, and then we get, and that's being times by a minus cosec 5y cot y. So we get a minus 5 cosec 5y cot 5y. Okay? And now that we have this, well, if we want to find out dy over dx, we can just flip both sides. Therefore, we end up with dy over dx is equal to minus 1 over 5 cosec 5y cot 5y. So for this second bit, now we need to find dy over dx, but we need to find it in terms of x, okay? So right now, we've got dy over dx, but we have it in terms of y. So how can we change that cosec 5y and that cot 5y to be in terms of x? Well, the easiest one is, first things first, we know that from the question, we know that x is equal to cosec 5y. So that cosec 5y is fine, that's just equal to x. That's not the problem. The problem is that cot 5y. What can we do about that cot 5y? So with that cot 5y, well, this is a trig identity. So the trig identity is that 1 plus cot squared y is equal to cosec squared y. So we can just rearrange this and we can get a value for cot y. So in our case, if I scroll up, in our case, what do we have? Well, in our case, we have that 1 plus cot squared 5y. That would equal cosec squared 5y. And if we know that cosec 5y is equal to x, then therefore we know that 1 plus cot squared 5y must equal x squared, okay, because like cosec squared. And if we know that, we can just rearrange now. So we have cot squared 5y is equal to x squared minus 1. And then if we square both sides, we end up with cot 5y is equal to the square root of x squared minus 1. And now we can just put all of that into our equation. So if I go here, if we know that dy over dx is equal to minus 1 of the 5 cosec 5y cot 5y, then using what we just learned, we know that the answer would be minus 1 over 5x, because cosec 5y is just x, so 5x, and we know that cot 5y is the square root of x squared minus 1. And that'll be it for this video. I hope you enjoyed it. If you want to refresh your memory on some of the other differentiation methods, then feel free to watch some of my other videos. I'll leave it somewhere in this video, maybe on the chain rule, product rule, quotient rule. I'll leave a link to one of those videos somewhere on the screen. But yeah, I hope you enjoyed it, and I will see you soon.